Good morning, everybody. I can't be there this morning. I have to be at a meeting, so I want to keep you on pace for the AP exam. So I'm phoning this one in. So if you could turn in your packet to the next section where we're doing 512, which is the area between two curves. Throwing in a pun intended curve here, we're actually going to reverse x and y as well. So our objective is to find the area between two curves, but this time with respect to y. We've always found it with respect to x before, so this is a new one for us. So just a brief summary on calculating areas. If there's just one curve, we all know that under curve really means it's just bounded by the x-axis. We look and find the roots within the bounds that are given, so we know where the function crosses the x-axis. That allows us to rewrite the areas as separate integrals, positive if it's above the x-axis and negative if it's below. We evaluate the integrals separately, and then we add the absolute values of the regions. Okay, so when there's two or more curves, which we started to get into, we determine where the points of intersection are. That's kind of an important one, but it's within the bounds that are given. We determine which function is higher, or which one's above the other, and then we rewrite the areas as separate integrals. Okay, so we don't need to find absolute values, and I hope you guys all realize why we don't need to find the absolute value, because all that absolute value really does is it reflects any negative portion underneath the x-axis above the x-axis. All right, so now there's a couple new things to keep in mind. Let's move this over a little bit. Okay. When you're integrating with respect to y and x, I asked you last night to bring in a couple different colored pencils. So you're going to shade with a different colored pencil each region that is bounded by a different pair of curves. Upper and lower when it's respect to x, and then left and right, which we'll see when it comes to integrating with respect to y. We're going to draw the shading vertically for dx and horizontally for dy. This is new for you guys. Horizontally for dy is new. Oops. Okay. All you have to do today is write the integrals. You don't have to evaluate them. Just set them up. All right? And we've seen this before when we have two curves and we're trying to find the intersection between two curves that are bounded by a and b. You just take the function which is above the upper function and you subtract the lower function, and then it's all with respect to x. Notice the brackets or parentheses here. You always want to include everything in the integrand within parentheses, especially if there's multiple terms and dx on the outside. I noticed on last week's test that people who are not well practiced in doing that often made mistakes on very straightforward problems when that is done. What's new is this piece right here when we're integrating with respect to y. Okay, when we're integrating with respect to y, we're going to take whichever function is to the right and then subtract whichever functions to the left. And then we will have different limits of integration, as you will soon see. Okay? All right. Oops. All right, so turn the page. Oh, not letting me take that in anymore. All right. So this is the one that we're most familiar with, integrating with respect to x. And here are the two equations, y equals x squared and y equals x plus 2. So one's a parabola and the other's a line. The very first thing we do is we find their points of intersection. Okay, so these are the x values, -1 and 2. So when we integrate, we're going to integrate from -1 to 2. And the upper function on this interval is the line. I can see the lines above. So I'm going to take the upper function and subtract the lower function, which is the parabola. And I'm drawing colored, shaded vertical lines to represent that. Okay, now here's the new piece. Okay, so let's just take a read up here. The differential used is dy. So the first thing we have to do is we have to take these two equations, which are solved for y, and we need to solve them for x. Okay, I did that over here. There. Okay, so if y equals x squared, solving for x, I get x to equal plus or minus radical y. So that's what this function is. In terms of x, on this side, I've got x equals plus rad y. And on this side, I've got x equals negative rad y. And the equation of the line now is written in terms of x equals. All right. So let's see how this looks different. So when we're differentiating with respect to x, we take the leftmost bound and we go towards the rightmost bound, and it's always with respect to x, looking at the x values. Well, now what we do is we kind of have to turn our heads 90 degrees clockwise, all right? And when we're integrating with respect to y, we look to see what the lowest y value is. The lowest y value occurs here at 0. The largest y value occurs up here at 4. See the 4 right here? Okay. So if I'm integrating with respect to y, I'm going to integrate from 0 to 4. So I'm integrating from bottom to top. Whereas when I'm integrating with respect to x, I'm integrating from left to right. So now everything's going to be in terms of y. All right. Now I notice that there is an intersection point here. So I need to integrate the blue area because that's where the first intersection occurs. So the y, the interval for y is going to be from 0 to 1. So that's where that intersection is. And that's what I have here. So I'm going to integrate from 0 to 1, the function that's on the right side, which is radical y. And then I'm going to subtract the function that's on the left side, which is also, I'm sorry, which is negative radical y. So this should say radical y minus a negative radical y. That's a mistake. That should be a plus sign. And then with respect to y. Okay, the next section of when I'm integrating with respect to y is going to be everything above this horizontal line at 1. So I'm just going to go from 1 to 4. And again, the function that's to the right is x equals rad y. And the function that's on the left is the line, x equals y minus 2. And that's how we have set it up. Why don't you put the video on pause for a minute and do the 2 problems down below, and then I will advance this and you can compare your notes and see how you did. Okay, hopefully you have done problem number 2. I have this thing blocking the screen. Again, this is your last chance to put on pause before I reveal the answer. And okay, so just as a recap, remember when you're integrating with respect to x, you're going to do the upper minus the lower. When you're integrating with respect to y, you're going to do the right function minus the left function. All right, so I'm going to drop this down. Okay, so this is what it should have looked like for the next 2. Again, put it on pause right now and give everybody a chance to take a look at that and then move on to the next problem. All right, I went back to problem 1 for just a minute because I just, in case I didn't emphasize it, anytime you are doing 2 different integrals, I want you to change the color of your pencil. And that's why this bottom part here is shaded blue and the top part is shaded red, representing each of these integrals. All right, I wanted to keep this mini lesson under 10 minutes, and I see that I'm right here at that point. So I'm just going to leave this screen on here. You can pause the screen, pause the video, I'm not going to do any of the remaining problems. You're supposed to finish the problems that you can in class and tonight in homework, and I will send out an answer key later today for you to check your work. See you tomorrow.